A rotated volume of interest is useful in many situations. For example, a scanned sample like a bone might be slightly oblique or oriented in a different way than other samples, and we want to rotate it to align it. Or we may want to analyze a specific subregion of the scanned object that is not aligned with the main axis. To get started, we click Wizard and create completely new workflow. Just select an image, right rotate, and use define rotate the image VOI. You can already now start the workflow, switch to runs, start a new run, select our image. You can take a first quick look at the image. And if we adjust the transparency, we can see that the bone is slightly oblique inside the image. The blue box always indicates that an interactive step is ready, and we double-click to open the user interface. As always, we have the cancel button and the finish button to abort or complete this step, and the update template button to remember the current VOI as a template for further images later. Here we also have another button to restore the VOI from a previous session. Here we can enter numerical coordinates or manipulate the volume of interest directly by interacting with the white box. We see a preview of the selected region in the 3D view. The square corner handles are used to resize, while the circular handles are used to rotate. In the 3D view, we can also freely rotate in all directions using the right mouse button. We can always click the reset button to start over completely. Or we can reset only the rotation or size independently. In the 3D view, by default, the gray part inside the VOI is quite opaque, and the red part outside the VOI is more transparent. But we can adjust this easily with the contrast and color tools. For example, to adjust the transparency of the image, change red to green, turn the outside context completely opaque, invisible, or mostly transparent. Seeing this colored, semi-transparent contextual information can help to fine-tune the VOI and make sure the entire object is selected properly. Sometimes it's also helpful to make even the background air visible, so we can orient ourselves better and visualize the entire selected volume. Finally, when we have our desired result, we click the Finish Job button. The workflow then usually continues with a cropping step that resamples the image in the new orientation. We can double-click that task to view the new created image, where the bone is now aligned to the image axis. We can also go back, open the original image to compare. We can also always open the VOI result itself to see the rotated box in context of the original image. Beyond these basics, there are a few more advanced tricks related to rotated VOIs. In the workflow editor, we can temporarily stop the workflow and extend it further. Here, I add a second image to be processed together in the same workflow run. I can then just reassign the VOI to crop out the exact same region in that second image. In this case, the second image is a binary mask. For binary masks, the resampling method should always be switched to nearest. Now we can start the workflow again and switch back to the workflow run view, where we select the corresponding binary mask image, which has the same oblique orientation as the first image. The next step of the workflow gets now executed automatically and reuse the rotated VOI and resample the mask to create a new nicely aligned image. We can always go back and redo or fine-tune the interactive step by selecting New Job and then click the Restore Previous button. If we only want to analyze a specific section of the bone, we can define a region relative to a specific biological landmark site, like the growth plate. So just resize the box and click Finish Job again. The workflow then automatically crops out that section of the bone and the corresponding section of the binary mask. If there is one or more related regions that are offset relative to the landmark, it is best to use the task called Adjust Rotated Image VOI. It can be configured to move or resize the region to create additional related regions automatically. For example, we can move the region a specific distance along the bone direction. After changing the task configuration, use New Job to rerun a task with the new settings. We can now analyze the region by appending further tasks. As a placeholder, I append the thickness transform. However, this task only works with an isotropic voxel size. The resampling process can lead to slightly non-uniform voxel sizes. If this is important, we can again go back to the rotation step. We actually see here in the sidebar the voxel sizes. The original size was 10 micrometers, but due to the interactive free resizing and arbitrary aspect ratio of the VOI, the resampled image cannot use exactly the same voxel size. But we can just click the isotropic button to snap to positions that allow using appropriate cubic voxels. The task can actually also be configured to automatically enforce isotropic voxels, so one does not have to remember to click the button each time. And with the isotropic voxels, the thickness was now successfully calculated. Another related task type is Invert VOI. You can connect that to the non-adjusted VOI that was used to calculate the thickness result. This then allows us to transform the thickness result back to the original oblique image space. We see now the VOI where the thickness result image would be located in the original image space. And we can use it, for example, in compare views or further process it in this space. If you have any questions, leave a comment below.